Hello everyone, welcome to What the Heck Math. Today we're going to talk about the differences between instantaneous rate of change and average rate of change. And this is not going to be a very long or in-depth video, but it's an important idea so that you can understand the importance of calculus, especially the beginning calculus. Okay, so first let's look at average rate of change, because it's probably something hopefully something you are familiar with. You may not be familiar with the terminology, but you probably have done something like this already if you have taken any kind of algebra classes. Okay, let's look at it two different ways. All right, so let's say we're going on a road trip. All right, so we're in a car, and welcome again to my ugly drawing skills. Alright, so we're going on a road trip, and here's the road trip. Alright, so we've reached our destination. Okay, so let's say the distance that we drove was 100 miles. And it took us 2 hours to drive that distance. What is our average speed? Okay. Well, to calculate average speed, we just take the distance traveled divided by the time it took to drive that different distance. So 100 miles divided by 2 hours is equal to 50 miles per hour. Okay, that's average speed or average rate of change. So very simple example, and depending on these values you might get something else, but total distance over total time traveled gives you average speed. Okay, another way to look at this. Okay, so let's look at a function, or at least the XY axis, right? So let's say I have, actually no, let's do something different. Let's just change them. All right, let's say we have a function, and let's just do y equals x squared in just the first quadrant. Okay, so there's y equals x squared. All right. So we had this point right here, and let's call that, I don't know, 1, 1. And let's call this 2, 4. Okay, and again, this is y equals x squared. All right. Now, I want to find the average rate of change between these 2 points. Okay, so average rate of change between these 2 points. All right, so what I'm going to do is I'm going to draw, as best as I can, a line connecting these 2 points. That's not bad at all. I wish it was a little darker up here, but that's okay. All right, so I'm going to draw a line connecting these 2 points, and as far as an XY graph, rate of change, or ROT, is equal to slope. Okay, and hopefully you know that slope is equal to change in y over change in x, delta y over delta x. Okay, so I can just find the slope of this line, and I will have the average rate of change between these 2 values. Okay, so slope of the line, well, I'm going to find the change in y, which is 4 minus 1, over the change in x, which is 2 minus 1. So that gives me 3 over 1, or 3. And there's my average rate of change. Okay, so basically the slope between 2 points. Okay, so hopefully that gives you an idea of what average rate of change is. Okay, now let's go back to our road trip. Alright, so here's our road trip. Now we're going to look at instantaneous rate of change. Alright, now just to recap of what average rate of change was. Alright, so basically you can look at it this way. If our starting position is at mile 0 and our ending position was at mile 100, our starting time was at time 0 or hour 0, and our end time was at hour 2. To find our average rate of change, we did our end position minus our starting position divided by our end hour minus our starting hour, which then equals 50. Okay, we didn't include these because it wasn't really necessary, but that's actually what we're doing. And if you look at this, it kind of looks a lot like the equation for slope. Change in y over change in x, change in distance over change in time. Okay, so yeah, it is basically calculating the exact same thing, just different units. Okay, now that gives me the average rate of change. Now, hopefully you know that just because the average speed was 50 miles per hour, it doesn't mean the car was traveling 50 miles per hour the entire time. Okay, so like maybe in this area you were on a toll road and you were going 80 miles per hour. This area you were stuck in traffic, so you were going like 10 miles per hour. At this point right here, you actually stopped for 30 minutes because you got something to eat from a fast food restaurant or something. Okay, so your speed was not always 50. It was changing throughout the whole trip. It's just your average speed ended up being 50 miles per hour. Okay, so what if I wanted to figure out at exactly this point how fast you were going? I don't talk about your average speed, like your instantaneous speed. Okay, well, one way you can look at it is if you happen to recorded a video of your speedometer the whole time, and then you can just look at where the needle on the speedometer was. Okay, but I don't know many people who do that. Okay, but I want to know exactly at what speed were you going at this instantaneous point. Okay, so I mean, if I were to zoom in on that point, it would not get any bigger. It's still just a point. Okay, so I want to figure out my instantaneous rate of change, or my instantaneous speed at that point. Okay, so we have to use this same formula to solve that. Okay, well, let's call it, this is about halfway, so let's say this is at mile 50. Right, so what is the starting point of that single point? Well, 50. What's the ending point of that single point? 50. Alright, well, what's the starting time of that? Well, let's say it's that time, I don't know, 3/4 of an hour. Okay, well, starting time is 0.75, ending time is 0.75, so we get 0 over 0, which is undefined, so that means there is no instantaneous speed. But that can't be right. I mean, we have speedometers. Speedometers tell us how fast we're going at the point when we look at it. So instantaneous speed definitely exists. It just, for some reason, we can't calculate it, which doesn't make sense. Well, let's look at something a little bit more mathematical. Okay, a graph. Okay, so y equals x squared again. All right. Well, we calculated the average rate of change between 2 points. What if I say, oh, I want to know the rate of change at this point? I want to know the slope at this one point. Well, hopefully, if you remember from algebra, you cannot calculate the slope of a line if you only have 1 point, because there are an infinite number of lines of different slopes that can go through that point. But I want to know the slope of this line at that 1 point, and I can't calculate it because the x is only 1 point, so that means the y values are going to be the same, the x values are going to be the same, and again we're going to get 0 over 0. Can't do it. Well, you actually can calculate the instantaneous rate of change of a single point on a curve using what's called derivatives in calculus. And that will also use limits, which I covered in 3 other videos. So if you want to know how to do that, please keep check out my next video. That's Introduction to Derivatives and Tangent Lines. Thanks for watching. Hope this was helpful. Please like, comment, subscribe, all that good stuff, and I'll see you next time.